Hey intellectuary viewers, welcome back to the intellectuary channel. Today we're going to be talking all about related rates, and so we're going to decode some related rates problems using my three-step logic, so you can solve any related rates problem easily. So let's go into this. So within our first example, let me just read the problem. There is a cylinder which consists of a radius of 10 meters. It's being filled with water currently at a rate of 6 meters cubed per minute. They're asking us how fast is the height of the water increasing within this problem. So again, the first step is to kind of highlight some things here, right? So let's highlight what information is important to us. So there's a cylinder, that's important, which consists of a radius of 10 meters, that's important. It's being filled currently at a rate of 6 meters cubed per minute, that's important. And then they're asking us how fast is the height of the water increasing. So I've just highlighted all the important information, and this is really the first important step before doing anything else, because it helps you identify the problem, it helps you identify different components of a problem that can help you solve it easily. So that's the first step, is to just highlight important information within the problem and things they give you. Now, the second step here, basically, it's the first step, is to identify the variables or the rates of change. And you have to draw the situation out, if possible. So right here, I've drawn a cylinder, right? Because this is a cylinder problem, right? They're talking about a cylinder, it consists of this radius, it's being filled with water at that rate. So here's a cylinder I've drawn with the height mentioned here, the radius mentioned there. So our first variable or variable of change would be dv dt is equal to 6 meters cubed by minute. And this is representing the rate of water being filled within the cylinder. So that's why it's the rate of volume, right? So dv in relation to dt in relation to time per minute. So we have that, and then what we're trying to find is dh dt, right? So we're trying to find the rate of the height of water increase in relation to time within this problem. So put a question mark there. We're trying to find that quantity. So our second or third step here would be to create an equation that encompasses both height and volume. So both these variables are rates of change. So what we can do is we can use a volume formula, because we know volume is a variable of change here, and say volume is equal to pi r squared h, and this is the volume of a cylinder formula, so we can use this. And because it relates both variables, volume and height here, so within this equation, so we can do volume is equal to, just plug in the radius we have here, which we have the radius of 10 meters, so we can plug in 10 here, h. So we get volume is equal to 100 pi h. So we get that. Now what we have to do is we have to differentiate with respect to time. So we have to do dv dt is equal to, let's see, 100 pi dh dt. So then we just have that. And so here within this equation, we can identify two things. One, that because we already have dv dt, right, that we can plug in dv dt here. So 6 meters cubed is equal to 100 pi dh dt. So just like any other equation, now we would solve this by dividing both sides by 100 pi, and we get dh dt is equal to see, dh dt is equal to 6 over 100 pi. 6 over 100 pi, again with units, meters per minute. So that's our answer, and basically if you use this problem, if you use this example to identify critical points, critical things within the problem, within the information they've given you, and use the same process, you'll most likely get the right answer. So let's move on to the second question. So I'll just read out the problem. There is a spherical ball who has a radius that is increasing at a rate of 5 centimeters per minute. Determine the rate at which the surface area, or SA, of the ball is increasing when the radius of the sphere is 12 centimeters. So again, let's highlight all the important information that we need to solve this problem. So there's a spherical ball. It's important who has a radius that is increasing at a rate of 5 centimeters per minute. To determine the rate at which the surface area of the ball is increasing when the radius of the sphere is 12 centimeters. So basically, our first step would be to identify, again, the variables or rates of change and draw, right? So I've drawn a sphere here with the radius, and we can use that to help contextualize our mindsets within this problem a lot more. So after we've done that, we can say, okay, we have dr dt, right? The rate at which the radius is increasing at a rate of 5 centimeters per minute. And we are trying to find ds dt, specifically when we can say r is equal to 8, right? So that bar just means evaluated at 8. So how we do that is we can create an equation, right? So we can use the surface area of a sphere formula. So S is equal to 4 pi r squared, right? So this is the surface area of a sphere formula that relates or has both surface area and radius involved. So this is a good equation to use. So we can say, because we're solving for ds dt, say ds dt, right? We're differentiating with respect to time dt. So is equal to 4 pi 2r dr dt, right? So then we have ds dt is equal to 4 pi times 2, and then we'll just plug in our given radius here. So 12 centimeters, 12 times 2. So then this would be ds dt is equal to, oh, this is 12, sorry. Ds dt is equal to, let's see, 12 times 2, 24 times 2 is 48. 48 times 4 is 192 pi. And then units, centimeters squared per minute. So that was our answer here that we've gotten. So we've basically utilized about 2 to 3 steps to solve each type of problem like this. Are 2 examples that we have in this video. And so any problem that you have similar to this problem, you just have to use a couple steps. The first step is to, first of all, highlight, right, all the important information that you need to solve the problem, such as, you know, they describe a shape, you have to highlight that so you can draw it later on. You have to highlight, you know, any important information such as a given radius or the rate of something, because the rate of something is basically dr dt or d s dt or whatever, but you can contextualize that within the problem to solve for the variable or rate of change that they ask you to determine. So within these few problems, I hope you guys learned a lot about how to solve these problems within related rates, and just to simplify the process for you guys, and to show you that related rates can be solved. Related rates problems aren't that challenging. It's just you need to get all the information in and contextualize a lot of that information, understand it in the context of the problem. So I really appreciate you guys. Thank you guys for watching. Please don't forget to like, share, and subscribe to this video, and don't forget to watch other videos on my channel.